Good morning. I hope you can see the desktop now and you can hear me. Does everything seem okay?
Yep.
Okay, great. Thanks. Okay. All right. So first, we're going to start a new topic today. We're going to start talking about arrays. But first, let me remind you that the next midterm exam is a week from today. It's going to be just like the last one, similar. First, anybody have any questions about these review problems? Has anybody had a chance to look at them? Does anybody have a question about any one of these problems yet? We can do that first. Anybody have a question about one of the review or anything else that's going to be any question about the exam? Anybody have any question right now?
I didn't go over the review questions yet, but which ones do you think we should pay attention the most?
Um, they're all they're all pretty basic. The answer would be all of them. Uh, a lot of these problems are kind of repetitious. Drawing these patterns, they're very similar. There's a lot of them because I think they're good practice. So the content of all these is almost exactly the same. Like those. It's almost exactly the same problem, but this same one here. But they're asking you to just keep practicing using for loops. So any one of them is good, but if you don't feel real comfortable with, like, if you can't solve one of these real quickly, you might need to do another one. So like these are, they're all pretty similar. They're asking you to do pretty much the same thing. Same with these if statement problems. They're pretty similar. Well, that's an if statement problem, and this one's another one about loops, real similar to the other ones about loops. Okay, so there's a lot of repetition in these problems. So it's really loops and if statements. Yeah, it's mostly loops and if statements, and a little bit about methods. And yeah, definitely do the ones about methods though. Uh, these. So if you definitely make sure you can do that's real important. Yeah, so I'd say what's real important is these problems on methods. Okay, all the problems about methods are real important. And yeah, these farther down, yeah, quite a few of these are about methods. Okay, this is back to nested for loops. Okay, this one's a method with an if statement in it. All the ones about methods are real important. So this is all very basic stuff in the sense that all of it is absolutely crucial to being good at programming. So that at a level like this, it's really hard to say that one thing is more important than another because everything in here is crucial to being good at becoming getting through a harder course like the data structures course next year. So everything in here is really important to understand. But some of the problems are more repetitious than the others. So all these nested for loop problems are pretty repetitious. The problems on methods aren't repetitious. They're not just variations on the same problem. So the problems on methods would be really good to make sure you do all of those. Okay. Um, okay. What about any other question about the programming assignment? Uh, about the problems, the review problems.
Can we do one of the method ones? So just for reference, when I do the
Let's see.
review today.
Okay. Like here, problem 12. See, if I was going to solve that problem, go to Java Visualizer. Good idea is to just like paste the problem in here so you can see it. Okay, so I can paste the problem in there. So okay, it says write a complete definition for a public static method. So we're going to write a public static, okay, now method called close enough, okay, that takes a double and an integer. So that means this has got inputs now. There's a double input. I can just call it X. I don't really know what it's for, so I'll just use a name like X. And an integer, I'll just call it N, because I don't really know what they're for. So I'll just call it double and X and N. It takes a double and an integer and returns true if the double blah blah blah. And notice that what it returns is a Boolean. So that means over here the Boolean goes there. Now remember, from the idea of remember, every method definition has a declaration and a body, and the declaration's got three pieces to it: the name, the parameters, and the return type. So you got to make sure that that's what you look for when you're reading the problem description. You look for, first you have to write the declaration. What should be the name? What are the parameters? What's the return type? So over here, that's what I figured out so far. I know that it's called close enough. It takes in a double and an int, and I picked the names for the variable X and N, and it returns a Boolean. Okay, then I need to give it a body. Okay, then inside I have to figure out what it does. Okay, okay, this thing's supposed to return true if the double is within. Now, yeah, you read it and you have to turn the English into something to do. So there's no rules about this. You know, you read the English and you try to figure out what it's asking you to do. I'm going to return either true or false. So there's like an if statement involved here. So yeah, I could think, well, if something, I'm going to return true or false. Okay, yeah, it takes a double and returns true. And you can even say, well, if there's something, then I return true. Else, I return false. Okay. Now, I mean, I can kind of sketch that out. It says here, it returns true if something, and it returns false. Well, it returns true if something. You know, if it doesn't return true, it's going to return false. Okay. So now what would go in here? If the double is within 1 unit of the integer. Okay. What they mean is that if you think of it as like on a number line, okay, on the number line, there's this integer. I called it n. It's somewhere on the number line. Okay. Now, 1 unit away from n on the number line is the number n plus 1. And on this end, 1 unit away from n on the other side of the number line is this number n minus 1. Okay. This problem say, if the double is within 1 unit of the integer. So this is the range of the number line that's within 1 unit of n. It's all the numbers that are greater than n minus 1 and less than n plus 1. So here I can draw a little picture of it. Now, it, you have to somehow turn the English in the problem into a program. Now here I turned the English into the problem into a picture, which is not a bad way to sometimes figure out what you need to do. I made it into a picture that's saying the returns true if the x, you know, if x is somewhere between, well, it's 1 unit away from n, so it could be 1 unit to the right or 1 unit to the left. Okay, so over here, what I'm asking where if okay, n minus 1 is less than or equal to x. So x is greater than n minus 1, and okay, now x is greater than n minus 1 means I'm there. You know, that means I'm to the right of n minus 1. but I want to also be to the left of n plus 1. So I'm sorry, I wrote the wrong symbol. And x is greater than n minus 1, and x needs to be less than or equal to n plus 1. Okay. Okay. So the picture gives me a sense of what to do. If now you might say, how did I know how to draw the picture? Well, there is no answer to how I knew how to draw a picture. Everybody might come up with their own way of solving this problem. You read the English. It takes a double and an integer and reads true if the double is within 1 unit of the integer. Now, when I think of numbers, I tend to think of a number line. So if you give me a problem about numbers, I almost always draw myself a number line. I almost always draw a number line to help solve the problem. So to me, if you ask me to compare numbers or to solve a problem about more than one number, I think of them as sitting on the number line. And then you start thinking, well, one of the you want one of the numbers to be like x over here wouldn't be good because that's more than 1 unit from n. X over here isn't good because that's more than 1 unit from n. Okay, so x has got to be in this range here. So for me, the picture tells me exactly what to write. Okay, x is greater than n minus 1, and it's less than n plus 1. Okay, now if I want to finish this problem, I should do these tests. Okay, so take these tests and put them in main. See, you take the tests and you put them in main. Okay, and to make them Java, I need to put a semicolon at the end and make the other part a comment. So put a semicolon there and make that a comment, and put a semicolon there, make that a comment, and put a semicolon there. Okay, and if I want to see the answers, an easy way to see the answer is to create a Boolean variable to hold the answer, because then when we run it, the Java visualizer will put the answer in that variable, and that makes it easy for us to see if we got the right thing. Okay, and then I need to change the names of those, so that's going to be 4, 3, 2. Notice I'm kind of setting things up the way the Java visualizer would set things up. It's going to run your tests. It's going to run your tests, and this will create a little table for me in the Java visualizer. When it visualizes the stack, I'll see a little table of B1, B2, B3, B4 with what I should see is false, true, true, false. Okay, all right. So I think this would be enough. I have the method declaration. I have the body of the method. Doesn't have to do a whole lot. Okay, and in this case, it's going to return true if this is true and return false if this is false. Okay, so let's just check that this works. Okay, let me just go to the end. Okay, false, true, true, false. So I got the little table I wanted. False, true, true, false. Okay, if I want, I can actually watch it run, by stepping through it. But I don't need to. I can just see at the end. Okay. Now, actually, there's something about this problem. I wrote this in a really terrible way. Okay. This is actually this is correct, but I can write this a lot better. Okay. Let me do it again. What I'm going to do is I'm going to comment out the one that's actually not great. I'm going to comment out this one. Okay. Now I want to fix it so it's actually a little bit better. Okay. If this is a true statement, remember, the way if statements work is if this is a true statement, you do what's in this part. But if this is a false statement, you do what's in this part. Okay, that's how if statements work. But notice that if this is a true statement, I'm returning true. So that means if this is true, so this is essentially the same true, I'm returning true. So that means I'm returning this thing. If this thing is false, I'm returning false, which is the same thing what this is. So when this is false, I return false. When this is true, I return true. So that means I'm returning this thing all the time. So watch, this can be shortened to be the following. This can be turned into one line of code. Just change the if, in this case, to return. Return the value of this statement. See, I'm returning the value of this thing. If x is in the number line like that, this thing's going to be true. And if x is in the number line like this, this will be false. So I'm going to just return that. So what I want is just that one line. Return this statement, which is true when x is between n minus 1 and 1, and it's false when x is not between n minus 1. Notice that there's a little thing. If you ever write code where you're writing things like return true and return false, you probably can simplify the code. You probably I wouldn't say never. You never say never, but you should almost never write code where you return true and return false. That's usually a sign that you really can shorten your code to something much simpler. Okay, because essentially what you're doing is if this thing is true, you're returning true. That means that you're just returning this thing here. So if you see yourself writing something like this, think twice and say, can I make it simpler? Now let's check that this is still correct. Okay. Go ahead and just, okay, so false, true, true, false. See, and if I run it, every time you go down to the method, you just go to that one line and then return. Okay, the function is just that one line, and then you return. You get called again, and return, and get called again, and return. Okay, right. So that's the best answer to this one. That it can be done in just one line of code. Right. So when you're asked to write a method, you're being asked to actually do quite a bit of work. It's actually you have to figure out what it's asking for. So you have to take the words and from the words figure out what's being asked for. Then you have to say, okay, now that turns into a method declaration, which means I have to know what the name of the method is, how many parameters it takes, and what type they are. Sometimes you're told what the names of these variables would be. Sometimes you're not. Like here, it just said takes a double and an integer and reads true if the double, no, so I'm not giving them names, is within 1 unit of the integer. No, so I didn't give them names. So you pick names, okay? And you pick names that you think might be helpful. In this case, there's nothing really helpful about them. It's just a number, just two numbers on a number line. So there's nothing really they could be helpful. But you sometimes you'll be told in the words what those variable names are, and sometimes you won't be. Okay, so you write the declaration, the name, the inputs, and what it returns. So far, we're always going to write public static in front here. We'll always write that for now. Then you have the body, and then you have to figure out what are you going to return. Is it going to be one line like this, or maybe like before it wasn't one line, but it turns out that could be simplified to one line. But then that's the hard part. You have to think of, you just have to read the English until you're pretty confident that you know what it's asking for, and then you can write out what the code would do. And then there should be test cases that you can, like on Coding Bat, there should be test cases that you can test your idea with. If it's on an exam, you would test them by thinking, but if you have a problem like this on this review, you can take the test cases and make them part of your code. Make the test cases part of the code so you can just, there's the method, there's the testing of it. Okay. All right. So that's an example. That's what. Notice every one of these problems is different. There's much less repetition in these problems about methods than there would be in the problems about for loops. The for loops can look an awful lot alike. it's still good. It's good practice for you to do a lot of them. I think you should do, all these formulas that it's, if you want to be successful at the next programming class and in the data structures programming class and the operating systems class, you really need to program a lot. Programming is something that takes a lot of practice. So doing as many of these as you can is just really good for you. In the long run, it's really good for you. But the method ones are way more unique than the for loop ones. The method ones, I think, are the better ones to practice. The more important ones to practice. Okay. Any question about this one? That's a right answer. That's a better right answer. So on an exam, that's full credit. But if you're on a job interview, that gets you a job. That makes you look like one of everybody else. I'm not, and that's actually kind of not facetious. When people in a job interview write code this way, people realize that they know what they're doing. When they write code this way, they realize, well, they know what they're doing, but they don't realize that they're not doing it as good as they could be. So if you write that in a interview, they know something about you that you haven't quite made it to the point where you realize how this can be improved a lot. You'll never see this in professional code. You'll never see anybody writing like that. Okay, that would just get turned into that one line. Okay, so practice really helps in getting to where you can write it correct, and then start realizing when you can write it better correct. Okay, so there's correct and then there's better correct. Okay, so both are important. On the exams, correct is going to be enough. Correct at this level, it's the beginning programming class. Correct is what we're looking for, but we're also trying to help you start seeing where you can write better correct also. Okay, something like that. Yeah, that's just better. You can't write it any short. You couldn't write it any shorter than that. Okay. Oh, let me show you another way to write this though. Let me write this again. I'm going to write, okay. Here's a better, but not as good. Watch this. Okay, there's correct, but not very good. What's not good about that? Does anybody see why I would much prefer the top line over the second line? Does anybody have a sense what's wrong? There's nothing wrong with the second line, but why is the first line better?
Because the X is in the middle.
It's visually in the middle, right? Why is that a good idea?
It shows the equality. So one section's greater than or less than the X, and then X is less than or equal to the other section. So it just shows the two parts with the X in the middle.
Yeah, it's
easier to understand, right?
Yeah, well, yeah. To put it real briefly, it's way easier to understand. You're saying that X is between n-1 and n+1, that X is in here. See, notice that looks a lot like what you can't write. Here's what you are not allowed to write in Java. Remember, in math class, you would write it that way. X is between n+1 and n-1. Okay, in math class, that's how you would write this down here. In math class, down here, whoops. in math down here, you essentially say that you want x to be between n plus 1 and n minus 1. You want x to be between these two numbers. Okay, but inequalities like this are not allowed in Java. You have to write them with the and, because this says x is greater than n minus 1 and x is less than or equal to n plus 1. So there's an implicit and in here. You say it in words, but you don't write it. This way of writing the Java looks a lot more like the math. This way of writing the Java basically dares someone to figure out what this is doing. You got to sit there and go, well, x is less than n plus 1. So then you have to go down here and say, well, x is over to here. And then you have to go, and then you have to remember what you did over here. And you have to go, and x is greater than n minus 1. So that means x is over here. So that means I'm taking the intersection of these two. What's to the right of n minus 1, what's to the left of n plus 1. Oh, so they mean in between n minus 1 and n plus 1. And as logic gets more complicated, there's almost always going to be a nice way to write the logic and a messy way to write the logic. And as a good programmer, you're looking for like the easiest way to read it. The way that'll help people read what you're saying. That helps a lot. That's correct, but doesn't really help as much. Okay. Notice I put the larger number on the left, which over here, the larger number's on the right. I put the case for the larger number on the left. I put the case of the smaller number on the right, but the smaller number's on the left in the number line. So here I'm writing the code kind of the opposite of the way people think, and a lot of even professional programmers will write this because it's right, and they won't think, well, how can I make it easier for someone to read? So no professional programmer would write that. A lot of them would write this because that's just what, they might just realize that, okay, I need x less than n plus 1 and I need x greater than n minus 1. And then not think, oh, how can I make that more readable? Okay, so that might be, you might actually see that in a lot of people's code because they just don't think to make it, they don't do the next step, which is to say, now that I've got it right, how can I make it the most readable? And the most readable here would be to make it as close to math as possible. So that one's very correct. But it's not as good. It's not as good as doing it like this, because this one just mimics the math notation and it's easier to read. I got a number on the left on the number line. X has to be to the left, to the right of it, but X also has to be to the left of this larger number on the number line. So X is between those two numbers. Okay. All right. So that's a nice way to think about it. Question? Okay. So remember, there's right and then there's better. Okay. You definitely need correct. You need right, but then there's a word for this idea of going from correct to better and staying correct. It's called refactoring. People in programming call it. See, it's even got it. You just type refactoring. Disciplined technique for restructuring an existing body of code, altering its internal structure without changing its external behavior in a series of small behavior. What they're basically saying, this is giving a real wordy definition, make your code easier to read. Refactoring is when you take code that's working, but now you just ask yourself, how can I make it easier to read? So people call that refactoring the code. I'm not sure why they called it refactoring. That's kind of a weird word. But it's restructuring, rewriting existing, something that's already working, something that's always working, but you want to rewrite it, change its internal structure without changing what it does, make it essentially make it more easy to read. So if you wanted a short definition of restructure, it'd be take your code that's working and make it easier to read. Okay, take code that's working and make it easier to read it's even got a name, restructuring. Okay, so let's go ahead. Any question about this example? And there's a few others that are similar to this. they ask you to read a description of and then read a description of a method and come up with the definition of the method. Okay, let's go ahead and start talking about arrays. Okay, so we've got these two references on arrays. Okay, so we got these two references on array. We want to here's the idea. Actually, I have an example. Let me just jump to it. I have this example in written that. Let's look at it. We'll look at it in first. Let's look at it in Dr. Java. Yeah, okay. And Dr. Java didn't start up right this time, so let me close it. Start it again. Okay, here's a little programming problem. Okay, I'm going to create a scanner so I can ask for input. And then I want to prompt the user. I want to prompt the user for temperatures. Okay, I want a list of numbers that are temperatures. Okay, so I'm going to print the user how many days of how many numbers are you going to give me? How many days temperatures? Then I'm going to read in that number. Okay, then what I want to do is I want to find the average of the numbers they give me. So they're going to give me a bunch of numbers, and I want to find their average, so I can report to them what the average daily temperature was. So the goal is to compute an average daily temperature. Okay, so I'm going to use a for loop, and I'm going to loop from one. Okay, the number they tell me, I call it num days. So that's how many numbers they're going to give me. They're going to give me 5 days worth of numbers or 10 days worth of numbers. I'm going to need to add up the numbers because I want to compute an average. So to compute an average, I have to add up the numbers and then divide the sum by the number of them. That's how you compute an average. You sum up the numbers you're averaging, then divide by how many numbers you added. Okay, so then I can go in a loop and I can say, give me your day, your temperature. I'll read it in. I'll add it to my sum. Give me another temperature, read it in, add it to my sum. So this loop does two things. It reads in their numbers and it adds them to the running total. So it's creating a running total of the numbers. Then when I've done this many inputs from the user, there shouldn't be any more. So I just stop asking and I tell them their average. Okay, so if you compile and run this, okay, yeah, I'm going to give 5 days of numbers. Now the first temperature I'll say is 77. Then the next day was 89, say, and the next day was 57. Then it was like 88, and then say 90. Okay, and the average was 80.2. All right, all right. Now here's the problem. This is a setup to motivate another problem. Okay, what if I want to tell the user two things? What was the average temperature and how many days were above average? Okay, what was the average temperature and how many days were above average? Okay, the question is, how would I solve that? So think about, okay, so think if you can think, how would I go about, I've got what's the problem here? What's a trick? I want to know two things. I want to know right now. I'm telling the user the average daily temperature. Okay. What if I also want to tell them how would I do that? Does anybody see there's a problem here? Did anybody see, look at the code, think, what would I need to do to say how many days of their, like in here, if I look at this example I just did down below, the average was 80, below average, above average, below average, above average, above average. Oh, there were 3 days out of the 5 that were above average. Okay. So I want to tell the answer, I want the average and the number of days above average. Now look at my code. How can I add that feature to this code? What would I have to do to be able to add that feature? Does anybody see what the trick here is? What's the point of this question? What would I do? Think like you were a person. You're get programmed to compute. One way to think about programming computers is to think, what if I had to do it myself? What would I need to do? And then I'll tell the computer to do it. So what would I need to do to solve this problem? What did I do down here?
So you're asking to get what's above the average, right?
How many days there are above average?
So it'd be like a math dot above. I have to Google it. Hold on.
It doesn't need a form. What's the trick? Think about, here's these users input. There's going to give you 5 days numbers, 77, 89, 57, 88, 90. The average was 80.2. If I wanted to go back to my program and make it find the number of days above average, what do I really have to do now? It's a good problem. This is a good problem. Yeah, it really, the key here is motivating the idea of arrays. Can you see what, somebody think, what would I need to do? I mean, even as a person, I go through the list and add up the numbers, then divide by 5, that gives me the average. Then what do I do? Let me put it this way. Day 1, I get the number 77. Is that above average?
No.
How do you know?
Big. Because it's 77 is less than 80.2, which was
Yeah, but where did 80.2 come from?
I don't follow.
Well, you read in the number 77, right?
Right.
So what does the program do with the number 77? It read in the 77, and what did it do with it?
It used it to find an average?
Eventually, but what did it do with it? What specifically did it do with 77?
It added it to the rest, right?
It added it into the running total. See, it added it into the running total, which at this point was 0. So you got 77 plus 0. Then here you got 89 plus 77. Can I tell you whether that's above average or not?
So that one is above average, right? 89.
How do you know?
Because average is 82.
But how do you know that? You've only read 2 numbers so far.
Oh, I see. At that point, average is different.
Yeah.
Okay.
See, we have to think like a computer. Look at this code and think what it's doing step by step. Okay. It read in 77. Is there any way it can tell whether 77 is above average or below average?
So it would be at average, right? Like exactly, because it's just one number.
It's just one number. So, well, yeah, but is it above average or below average? Can the program tell you whether the 77 is above average or below average?
No, right? Because it's equal to.
Not yet. See, when it read in that number 77, it can put it in the running total, but it cannot tell you if it's above average or below average. Why not? When the program read in 89, it put it into the running total. It cannot tell you whether it's above average or below average. Why not?
Shouldn't be able to because average is in between, right? So it would be above
In between
average.
what?
77 and 89.
Okay, let me do this let me run the program again. Okay. 5 days of numbers. My first temperature is 56. Is that above average or below average?
That one is at average, right? At the moment.
At the moment, but that's not what I want to know.
Oh, not neither.
Here's my second temperature, 68. Is that above average or below average?
In my opinion, it's above, right?
No.
No.
What's the answer?
Is it still neither?
Pardon me?
Is it still neither of them?
It's still neither. You don't know. What is the key idea here?
Oh, there's 5 numbers, right? So it's waiting
Right.
for.
So when am I going to know what the average is?
After 5 entries. Right?
After 5 entries. So
Okay.
right now, I can't tell you if something's above average or below average. I won't know until I get all 5 of the numbers. The program is not clairvoyant. It doesn't see into the future. Okay, so here's a third temperature. I have no idea if that's above average or below average. Here's another temperature. I have no idea if that's above average or below average. Here's another temperature. Okay. Oh, well, the average of those was 60.8. How many of them were above average?
Four of them, right?
Well, let's see. Was it 1, 2?
Oh, never mind.
No,
Not
3 of them.
3 of
Okay.
them, yeah.
Now, what's the difficulty here? Now I want my program to tell me how many days are above average. What does my program need to do?
Needs to count the days that are above average.
How? That's what we want to do. How do we count the days that are above average? What can my now notice that I can't solve that problem in this for loop. Why not? Can I do why I cannot change this for loop and solve my problem? Why not? That for loop is doing what we just, that for loop is the loop doing this, right? So why is it that I cannot fix that for loop and solve my problem?
Because it didn't store the data, right? Because it was just adding.
Pardon me?
So it didn't store the data, right? It was just adding.
Yeah,
So
so
we
what
need
do
to
you mean
create
by
an
that?
array
You
or
know, what's
something.
the problem? Why can't this loop, you're getting at the right idea, but why is it that I can't fix this loop to count the number of days above average? Why can't I just do something here and fix it? Run it again. I'm in this loop. Well, not yet. Okay, 5. Okay, now I'm in this loop. I'm right here on line 18. Okay, on line 18, I give, okay, the temperature on day 1 was 78. Now I'm back to line 18. The temperature on day 2 was, say, 84. What's the problem? Why can't I fix that loop so that it tells me how many days are above average?
It's not storing data. I mean, that's the only thing I see. It needs to like push into an array, right? Or
Well, what's stopping me from telling whether 84 was above average or not?
it doesn't have 5 digits, 5 numbers,
Well,
5
you
entries.
haven't got to the end of the data yet. You can't tell if something is above average until you've seen all the data. See, at this point, I'm reading in the data. I read in an 84. There's no way I can tell if 84 is going to be above or below average. The next number might be 102, or the next number might be 40. Yeah, I don't know what the average is going to be. Okay, so I have to read in all the data before I can actually start saying what's above and what's below average. Okay, now here I'll read in all the data. Okay, now what would my program need to do now to find out how many days are above average?
Store the previous data and compare it to the
Well,
average, right?
one possibility is that I have to somehow remember these numbers. See, one possibility is that you somehow have to keep track of those. Because what do I need to do now? I really need to go back through these numbers and compare. The average is 72. 78 is above average. 84 is above average. 66 is below average. 70 is below average. 62 is below average. So there were 2 days above average. Okay. See, I have to go back through. Once I know this number here, I have to go back through those numbers there. How can I get my program to do that? What would be one way to do it? This is like, how, if somebody was, giving you a job interview and said, how do I do this with what we've done so far? What's one way? Come up with a way to solve this problem. How can I find out how many days we're above average? Using what you know so far. Using what you know so far, you can fix this. Maybe not in a great way, but you can fix it. What could I do?
You can start like an array, right? I'm not sure if
You
you're
don't
the same
know
thing.
arrays yet. I said
Oh,
using
okay.
what you know so far.
Oh, never mind.
So there's an easy way to solve this. Not exactly an elegant way, but there's an easy way to solve this. What's a way to get? How can I compute the number of days above average? Come up with a strategy. You've got a boss, he's impatient, he wants an answer. You've got to come up with a strategy. You got to come up with something. Doesn't have
So
to
if
be elegant, but it does have to solve the problem. How can I
what
find the days that were above average?
what if you assign like a int to each of the entries and then compare it?
Yeah, okay. If I wanted to save these variables, like how can I do that? I mean, that's not gonna work very well. Like when I read in this number, what if I want to save it? Okay, what that saves it, but what's wrong with that?
Oh, it's saving the sum, right?
No, no, it's saving the number it just read, saves it in X. I'm going to have a hard time saving these numbers like this. What's wrong with saving it in an X?
You need to define that x is a integer
That's easy enough to do, but
variable.
that's not a yeah. So int X, save the number in X. But what happens when I loop again?
You need a different value for x, right? Replace it
Yeah,
with
I
something
need an
else.
X. I would actually need like an X1, an X2, an X3, an X4. But how many of these X's do I need?
5, right?
Well,
That depending on the amount of numbers you put.
yeah, it depends on here. Like, what if somebody's going to give me 50 numbers? Then I'd need 50 variables. That's not going to work. I mean, I can't create 50 variables sometimes and 5 variables other times. What's another, what's a more practical, what's a way that'll work? What can I do to find the number of days above average? Again, I keep giving you, there's a way to do it. It's not hard, it's not elegant, but there's a way to do it. Think, what can I do? Think what I did here. I found the average, right? Then I went back and said, is that above average or not? 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 Okay. I looped through the numbers again. How can I loop through the numbers again? What would be your only strategy? There's really only one way with what you know now to try to loop through the numbers again. What might you do? Programming is about solving problems. I think you're not going to learn a program by just like waiting till somebody shows you how to write every possible program. You can't be shown how to write every possible program. You've got to write your own. The only way to write programs is to come up with strategies and talk about programming and talk about strategies. You have to come up with ways of doing things. So like now you have to come up, anything that'll work. Come up with a way. What can I do? I need to go back through these numbers again. What would be one way? I mean, it's probably about right now the only way you know now. What would be a way to go through those numbers again? Where did they come from? Where did
Inputs,
these
right?
numbers come from? Look, okay, the numbers came from the user. So ask the user for them again. Take this loop and just do it again. So now we'll say, we'll give them a different message. Just repeat the numbers again. Please repeat the numbers. Please repeat the temperatures. Yeah, and ask them to repeat them again. Now, but now I'll change what I'm going to do with them. So I asked them to repeat the numbers. Okay. the same number. They're not, this isn't going to change. So I want them to repeat the numbers. So I ask for day 1. I read that number. Now I do something different with it. What do I do with it now? I'm going through the numbers the second time. They give me this number the second time. What do I do with it?
You check if it's more or less than the average.
I have to ask if next was greater than or equal to the average. Oh, I have to put this loop after I've computed the average. So I have to move it. So I'll put it after I've computed the average. Okay, so now I can say if next is greater than or equal to the average. What do I want to do if that is greater than the average? What do I do with it? If the temperature was above average, what do I do?
Return it's greater than?
No, well, what do you mean return? What am I'm trying to, think about what I'm doing here. Down here, the average is 72. 78 is above average, 84 is above average, not above average, not above average, not above average. Oh, there's 2 days above average. What I'm doing, I'm counting how many days are above average.
Oh, yeah,
So
so
what
you're
would
just counting, right?
Pardon me?
You're gonna add 1 each time it's greater?
Yeah, I'm going to add 1 to something. So I'm going to create a variable called count, and I'm going to add 1 to it because I found a number is above average. But that means I need a variable now called count. So I'll create a variable count equal to 0. That's going to count the days above average. So I start out with a variable that has, okay, there's 0 days above average. Then I go through here. If I read a number, I ask the user to give me the numbers again. They go through their data again. And now when I read a number, instead of adding it into the running total, now I say, well, if the temperature is above average, I count it. Okay. When this loop is done, I can print out the number days above average equals count. Okay. So basically, I have to ask the user to give me the data again. That's one way to do it. If the user's got the data in front of them, they can just repeat it for me. Okay, so make sure I wrote this right, compile it. Okay, run it. Okay. So 5 days of temperatures. Okay, day 1 temperature, I'll make up numbers again, 78, say 87, 66, 90, 40. Okay. All right. Now I have to repeat the numbers. Okay. Oh, I forgot a carriage return after. Please repeat that the temperatures. Okay. So day 1 was 78. Day 2 was 87. Day 3 was 66. Then it was 90, and then it was 40. Okay. And there were 3 days above average. Okay. 1, 2, 3. 3 days above average. Notice that. So I had to ask so the solution would, to solve this problem with what we know now, is to ask the user for the data again. Okay. Now what we want to do is, what we really would have liked to have done was store their data as they were giving it to us. That's actually what we would have liked to have done. Instead of having to ask the user to input the data 2 times, we would really like to store the data as the user's entering it in. So that instead of having to ask them for it a second time, we could just look at the data again. And this is the problem that arrays are for. Now, I can't just create variables because I don't know how many pieces, I don't know how many days of data I'm going to get. The person might actually do something like, I mean, they might tell me that there's 1,000 days. Yeah, they might tell me that there's 1,000 numbers. Okay, now I'm ready to, I'm supposed to enter 1,000 numbers. Okay, that's more than I'm going to sit here and do. And I don't want to ask someone to enter 1,000 numbers again. But I can't create variables to hold, like for example, I could do the, I need a way of creating a lot of variables without knowing how many I need. Okay, this is what arrays are for. Arrays solve a really tricky problem. This is actually a really tricky problem. I don't know ahead of time how much data they're going to give me, but I want to remember the data. If I know I'm going to get 5 pieces of data, I can just create variables. For example, if I knew there was going to be 5 pieces of data, I just say int x1, x2, x3, x4, x5. If I knew there was going to be 5 pieces of data, I'd create 5 variables. If I knew there was going to be 10 pieces of data, I'd have to create 10 variables. Okay, now that works, but I have to know ahead of time how many numbers are going to be. Okay, so this is not a good solution because I'd have to know ahead of time how many of these variables I need. Okay, also in a for loop, I can't loop on the name of a variable. In this for loop, there'd be no way to talk about the 4th one of these variables. There is no way to loop on the names of variables. Okay, so that's another problem with this. If I create 10 variables like this, I can't use them in a for loop. Okay, there is no such thing as xi, for the ith one of these. Okay, so I have 2 problems with this kind of a solution. I don't know how many of these variables to create, and I cannot loop on x1, x2, x3, x4, x5. Okay, so that's not going to be a very good solution. Okay, so what programming language like Java did is they invented this idea of an array. An array is a way to create variables, a lot of them at once, with names you can loop on. Okay, so what I'm going to do is make a copy of this. I'm going to change it so that I'm going to change it to use a loop, to use an array. Okay, so watch what I'm going to do. Up here, I'm going to change that line to be something called an array. An array looks like this. I say, well, actually, yeah, okay. So I say int, and I use square brackets. Square bracket means that I'm going to create an array of integers, and I'm going to call them days. Okay, and then I'm going to say new int square bracket, and then I'm going to say how big this array is. The size of the array is num days. This creates these variables kind of like this with exactly the right number of them. Essentially what that does is it creates this many variables, and the variables, their names are days 0, days 1, days 2, days 3, ... What I just did is I created a whole bunch of variables. Their names look like this. There's the name of the array followed by an index into the array, the first number in the array. Then the name of the array followed by an index. This would be the second number in the array. Okay, so this creates a bunch of variables at once for me. Okay, and then down here, what I would do is I would say days. This is where I will remember their number. Days I'm in the ith day is next. Okay, this lets me remember what they typed in. Okay, Now I don't need to prompt them again, but I'm going to still need a second for loop. Okay, now my second for loop, instead of prompting for the numbers, can get the numbers out of the array they're stored in. So this would be here. This is where the numbers were stored. I would say if days I is greater. So now I'm going to go back through the array. And as I go back through the array, I'm going to step through each element. Oh, I have to start here with 0 though. Okay, we'll see. So I have to step through the array. Oh, and I need to make a change here. I need to go from start at 0. Since array indexes start at 0, I have to change my loops to start my loops at 0. I have to be real careful. We'll keep playing as we go through. We'll see how we have to be real careful about this. But the loop, these variables that I created by creating an array, the first one has an index of 0. Okay, so I start with I equals 0, and I go through, look at day 0. Notice it's no longer day 0. It's not day 1, day 2, day 3, day 4. It's day 0, day 1, day 2, day 3. Okay, so I go through and I find if that day's temperature is above average, count it, and then I can report the end. Okay, so now compile this. Okay, I want to call this temperature 2. Oh, let me cancel that. I have to change the name. This is the second version. Okay, so save it now. I'm going to save it on the desktop. Okay, so there's temperature 2. So it compiled. Okay, and I'm going to run it. Okay, now 5 days. I'll just stick with 5 because it's an easy number to work with. 5 days. Okay, first temperature, I'll make it say okay. Now the average was 75.6, and notice that it after I inputted the numbers, it went through and did this other loop real fast, and it told me the number of days above average is 3. And let's just check. Let's see. Above average, above average, above average, below average, below average. So the first 3 were above average and the last 2 were below. Okay. So I solved the problem without having to go back and ask the user again. Okay. So this is a good example of a kind of problem that gets solved with arrays. Okay. Now, the idea here is to see something that needed an array, a fairly simple problem, asking for data, then doing 2 things with the data, computing its average, but then computing how many numbers were above average. So I want to process some data, but do 2 things, find the average of the data and find how many numbers were above average. I have to go through the data twice. There's no way I can solve that by going through the data one time. You have to go through all the data to know what the average is. And then you have to go through all the data again to find out how many days were above average. So you have to process the data 2 times. That means the data has to get stored somewhere. So, but I don't know how much data there is until I run the program. So I don't know how much storage I need until I run the program. And this is the problem that arrays solve for us. They let us create an arbitrary amount of storage when the program's running. Okay. Now let's go to this Java visualizer and just play around with arrays in the Java visualizer. So I'm going to go up to the Java visualizer and do some playing around with arrays so you can see them happen. The Java visualizer is great for playing with arrays because we can just kind of see them happen. Okay. Here's how I declare an array. An integer array would look like that. Okay. If I do this, I'm creating one integer. If I do this, I'm creating an array of integers. Okay. Now, if I'm creating one integer, I say what number to put in it. If I'm creating an array of integers, I'll call it A instead of X. If I'm creating an array of integers, well, I have to say how big it should be. So after saying an integer array called A, I say I need a new, arrays are objects. So I've used the word new, say int and I'm going to create an array of size 8. Okay, I say I want a new array, how big it is. Okay, now I can just visualize this already. This is a program. Okay, there's a variable, there's the array. See, the array is this thing over here that's got 8 slots in it. Now the visualizer is unfortunately the visualizer compresses the arrays. I wish there was a way of saying to show there's really 8 slots in this array numbered 0 through 7. Okay, and I wish that we could get the visualizer to show us the whole array. Sometimes it shows you the whole array, sometimes it doesn't. But notice that the array is an object. See, it's over here on that side of the picture. An int is a primitive. So the 5 sits in the int. But an integer array is an object. The integer array sits over here. Okay, because it's too big. Essentially, it's too big to sit over here. So it goes in the object thing, because I could make this an array of size 8,000 if I wanted. So this can be very long. Okay, so that creates an array, and notice that the numbers in them are just 0. Initially, they start out as zeros. Now I could create different sizes of array, like I could create an array of size 3 if I wanted. See, now here it showed me the whole array. Array of size 3 has 3 slots. I think with 4, let's see 5, if it'll show us the size 5. Nope. Maybe 4 was the, yeah, it wants to compress the visualization of the array. It didn't even show size 4. Okay, so it went up to 3. So it was 0, 1, 2. It went up to size 3, and then it just shows dots for what's in between. Now let me show you one last thing. I can put something in the array. If I want to put something in the array, I say A3. I'm putting something in slot 3. Slot 3 is the 4th slot. I'm going to put the numbers, say 17 in there. Okay, there's the array. Now notice that now it has to show me the whole array, because I put something in slot 3. So now it shows me that the array has got 4 slots, 1, 2, 3, 4, and I made the slot number 3 a 17. Okay, and if I make the array, say 24 items, and I put something in the 23rd one, I'll get a bigger array. Okay. Oh, I didn't put it in the 23rd. Oh, I didn't. I want it in the 23rd item. I want to put a slot number. Okay. Oh, and it still did the dots. So there was a 0, then a bunch of zeros up to the second to the last entry in the array, and then the 23 was at the end of the array. Okay. The visualizer lets us play with arrays. So we'll do this when we come back. Let's see, today is Thursday. So on Tuesday, we'll do a lot of playing around with the visualizer to create arrays and play with them and see how that they work. Okay. And the key is that what we're trying to do is we want a technique that lets us solve problems like this. The key idea here was I need a lot of variables, but I don't know how many until the program runs. It isn't until somebody tells me how much I need that I can actually create the array. So I need a way when the program is running to create lots of variables at runtime. So, and I want them to have names that I can step through in a loop. So that's what arrays give us. We can choose how many there are when the program's running, and then we get names that, not unlike these names, which you can't loop through. These names you can loop through. You can put a variable in there. You can put a variable in there. You can't put a variable there because you can't make a variable part of a variable. So X6 can't be made something that you can loop on. You can't loop on X6, X7, X8, X9, but you can loop on days bracket 0, days bracket 1, days bracket 2. So arrays are real powerful. You know, they form a huge part of what we do with programming. Arrays they're very useful because you can make the size of them, you can make them as big as you need them at runtime, and then you can loop through the names in the array. Okay, so we'll quit there. On Thursday, we'll do a bunch more examples of playing around with arrays, mostly in the Java visualizer, get a sense of how to work with arrays. Okay, so if you have questions about the review problems, let me know. I can, you know, I won't give you the solutions, but if you have questions, I'll answer questions and tell you if you did anything right or wrong. So keep working on the review problems, and then have a nice weekend, and see you on Tuesday. Bye.
Have a good day.
Bye.